Now, the moon is 60 times as far away from the Earth's center than we are. We're 4,000 miles away from the center, and the moon is 240,000 miles away from the center. So if the law of inverse square is right, an object at the Earth's surface should fall in 1 second by 1/20th of an inch times 3,600, being the square of 60, because the force has been weakened by 60 times 60 for the inverse square law in getting out there to the moon. And if you multiply a 20th of an inch by 3,600, you get about 16 feet. And lo, it is known already from Galileo's measurements that things fell in 1 second on the Earth's surface by 16 feet. So this meant, you see, that he was on the right track. There was no going back now. Because a new fact that was completely independent previously, which is the period of the moon's orbit and its distance from the Earth, was connected to another fact, which is how long it takes something to fall in 1 second. So this was a dramatic test that everything's all right. Further, he had a lot of other predictions. He was able to calculate what the shape of the orbit should be if the law were the inverse square, and found indeed that it was an ellipse. So he got 3 for 2, as it were. In addition, a number of new phenomena had their obvious explanations. One was the tides. The tides were due to the pull of the moon on the Earth. This had sometimes been thought of before, with the difficulty that if there's the pull of the moon on the Earth being here, the water's being pulled up to the moon, then there would only be one tide a day where that bump of water is under the moon. But actually, you know, there are tides every 12 hours roughly, and that's 2 tides a day. But there was also another school of thought that had a different conclusion. Their theory was that it was the Earth that was pulled by the moon away from the water. So actually Newton was the first one to realize what actually was going on, that the force of the moon on the Earth and on the water is the same at the same distance, and that the water here is closer to the moon and the water here is further from the moon than the Earth, than the rigid Earth, so that the water is pulled more toward the moon here, and here is less toward the moon than the Earth, so there's a combination of those 2 pictures that makes a double tide. Actually, the Earth does the same trick as the moon. It goes around a circle, really. I mean, the force of the moon on the Earth is balanced, but by what? By the fact that just like the moon goes in a circle to balance the Earth's force, the Earth is also going in a circle. Actually, the center of the circle is somewhere inside the Earth. It's also going in a circle to balance the moon. So the 2 of them go around a common center here. And if you wish, this water is thrown off by centrifugal force more than the Earth is, and this water is attracted more than the average of the Earth. At any rate, the tides were then explained, and the fact that there were 2 a day. A lot of other things became quite clear. Why the Earth is round, because everything gets pulled in. And why it isn't round, because it's spinning so that the outside gets thrown out a little bit and it balances. And why the sun and moon are round, and so on. Now, as the science developed and measurements were made ever more accurately, the tests of Newton's law became much more stringent. And the first careful tests involved the moons of Jupiter. By careful observations of the way they went around over a long period of time, one could be very careful to check that everything was according to Newton. And turned out not to be the case. The moons of Jupiter appeared to be first get sometimes to 8 minutes ahead of time and sometimes 8 minutes behind schedule, where schedule is the calculated values according to Newton's laws. It was noticed that they were ahead of schedule when they were close, when Jupiter was close to the Earth, and behind schedule when it was far away, a rather odd circumstance. And Mr. Römer, having confidence in the law of gravitation, came to an interesting conclusion, that it takes light some time to travel from the moons to the Earth, and that what we're looking at when we see the moons are not how they are now, but how they were the time ago that it took the light to get here. Now, when Jupiter's near us, it takes less time for the light to come, and when Jupiter's further, it takes longer time, so he had to correct the observations for the differences in time, and by the fact that they were this much too early or that much too late, was able to determine the velocity of light. This was the first demonstration that light was not an instantaneously propagating material. I bring this particular matter to your attention because it illustrates something. That when a law is right, it can be used to find another one. That by having confidence in this law, if something is the matter, it suggests perhaps some other phenomenon. And if we had not known the law of gravitation, we would have taken much longer to find the speed of light, because we would not have known what to expect of Jupiter's satellites. This process has developed into an avalanche of discoveries. Each new discovery permits the tools for much more discovery, and this is the beginning of that avalanche, which has gone on now for 400 years in a continuous process, and we're still avalanching along at high speed at this time.